The recorder is now on. Okay, this is the regularly scheduled meeting of ITSC 2309 for July 9th, 2019. Let's see, I'm catching up my grading. I haven't started grading test one yet, and that usually takes me a little while to do that because I grade them all at the same time. In other words, I grade all of problem one and then all of problem two, and this helps me to keep it consistency, and everybody gets the same test there. Let's see, I wanted to back up a little bit. This one comes from, I believe, let's see, this is what, module 2, 3, 4. Module 4, I guess. Anyway, it's got that challenge problem in it. Where is that one? That is, okay, I believe it's, okay, this one asked that number 8 was a challenge, and it said to find all invalid problems. And this particular one, person who wrote this may recognize their writing. That's fine. I'm not going to put the name on it. Actually, I thought it was pretty good. But it does highlight a couple of things I wanted to bring out here while we're talking about that. By the way, somebody talk to me and let me know I'm getting through. Mr. Griffith, talk to me.
Yeah, we can hear you.
Okay, cool. Let's see. So this one said, find all of the invalid rows, and a row, and then I told you a row was valid when the balance due, and in this case, the balance due was invoice total minus credit total plus payment total is greater than 0, and the payment date is null, or it's equal to 0 and the payment date is not null. So that makes it a valid row. And for this particular student, they wrote they had a valid row. So when they ran it, and by the way, I did accept it as an answer. When they ran it, they got 112 rows. So 112 rows had valid records in there. But I didn't ask for valid records. I asked for invalid records. Let me back up there. I just wiped out something. Undo, undo, undo. Okay, there we go. I asked for invalid records. Now, what's an invalid record? Well, an invalid record is where this is not true. So in order to get that, so this particular person wrote a very good select from where query where the is valid. So it's valid if the balance due is greater than 0 and a null payment date, or the balance due is equal to 0 and the payment date is not null. In other words, it's been paid. And I say it's close, but it's specified in terms of valid rows, and then it asks for invalid rows. So to fix that, it's pretty easy. All you have to do is put a not in front of it. So if you put a not in front of it, and notice I put the parentheses there, such that they bracket it like that. So I like those parentheses. When I do something like that, I like to really call your attention to these parentheses. And I like parentheses that match the ones below them. Okay. So when I run this, I'm going to find that there are 2 rows. One has a null payment date and a 0 balance due, and the other one has a payment date and a non-zero balance due. So one from each of the 2. A couple of other things I'd call your attention to on this one. This particular person has a, or at least looks like I might have put that in there accidentally. There's an empty line in here anyway. And it is best if inside of a query, that's inside of here. Up here it doesn't matter. That's outside the query. But inside of the query, between the select and the closing semicolon, don't have any completely empty rows. If you want to have something that's empty, go ahead and put a dash dash on that line to give it something there, because many platforms will throw an error there, although SQL Server will not. Okay. One other issue here, let's take a look at this guy. I'm going to slide over a little bit. This set of parentheses right here is not needed. I can lose this set, and it will be the same, and this set. It'll be the same. Now, it's not always bad to have them around it. In fact, I didn't even comment it in the person's code. I didn't make any comments at all about that set of parentheses, but it's not needed in SQL. But in some languages, it will be needed. And the other question is, which one comes first, the and or the or? For example, if I were to talk about, the example that I use a lot is you must, I think I have it up there, and I think I have it in the module with and or. The idea is that and comes before or. So you must actually hit the ocean with OC. You must actually hit the ocean with your bullets. This is my example for the naval marksmanship badge. You must actually hit the ocean with 4 out of 5 rounds, and attend range safety class, or complete online range safety module. Okay, so in order to get so this is the naval marksmanship badge requirements. So it's kind of silly. I mean, I know you must actually hit the ocean with 4 out of 5 of your bullets, and you must attend a range safety class. But if you can't do that, you can complete the online range safety module. And the question then becomes, when would we give you the badge, or the marksmanship badge? And what do you have to do to get the marksmanship badge? Well, they probably mean that they want you to do this one and one of these. But the language here and the logic of this says that you can get it just by doing this third one. Now, the reason for that is that the and comes before or. So if there is no other language in here that tells me which way to do this, I'm going to put these two guys together first. Okay, so did you hit the ocean with 4 out of 5 rounds? Well, no, you didn't. Did you attend the safety class? Maybe you did, maybe you didn't, doesn't matter. Or whatever the outcome of that, you can complete the online safety module. The or would dominate here, in that if this one were true, you would get the whole statement would be true, because the and is evaluated first. Therefore, if you don't have any other way if there's nothing else in there, then it would be evaluated like that. In other words, it would put the and together first. So this is the default. So whether this is true or false, whatever, it doesn't matter whether this one is false or not. If the last one is true, it pulls the whole statement to true. And the reason for that is that and dominates. And comes before or. and is evaluated first, put together, then it puts together the ors. In the case of the above, it works just fine because notice we have the and that is what we want here. We want this one to get put together first, put this one together, and then apply the or to all of them. So it works okay. I might put the parentheses here. I don't have to put parentheses here because that's the way it's going to get evaluated anyway. I might put parentheses here. There is nothing wrong with having an extra set of parentheses. Okay, that it's not really doing anything. But there's nothing wrong with it. And if that helps you read it, then it helps you show what your plan was in that. It's perfectly acceptable. Okay. I believe I have this in the module as an example. It's one that I use quite a bit. If you are ever in a lawsuit with and or, they will always evaluate the ands first. Think of and as multiplication and or as addition. Okay, so that's kind of the way it works. It's like 2 times 3 plus 4 is the same thing as 4 plus 2 times 3. The times gets evaluated first. So it puts those guys together and then it adds them. The same thing works with and or. It puts all the ands together and then it puts the ors. Then it puts the ors in there. So think of and as multiplication and or as addition. And in fact, in many syntax for writing and or, they will write and as multiplication and or as a plus sign. When they're talking about the logic, when they're writing logic mathematically. Questions? All right, well, let's move on to the next module then. And we are now beginning Module 8. Module 8, let me get back. Previous. Introduction to subqueries. And let's see, is this Dr. King's writing here? I don't know that it is. We're going to talk about introduction to subqueries, and the text reading assignment is page 183 through 207. Okay. We've finished chapter 4, and I want to find all of the vendors' names who have no associated invoices, and you may as well get used to this one. It's a very common one. I want all of the vendors who do not have an invoice. Well, what kind of a query are we looking at here based on what we know up to this point? It is a childless parent query. There's nothing wrong. There's no errors here. It's just a parent does not have to have a child. So we're now ready to talk about it. Since we finished, we recognize that it's called the childless parent query or an outer join. So anytime I'm looking at childless parents, I need an outer join. So what tables are needed? And I answer them for you there, the vendors and the invoices tables. How are they related? Well, vendor ID is the primary key of the vendors table, and it's a foreign key into the invoices table. From which table comes the unmatched rows? It comes from the vendors table. So I'm going to have an outer join pointed at the vendors table. So those are the 3 questions that you'll answer. You might have more than 2 tables, but 2 is common. So we're ready to write the query now. And if we were to write the query, it would look something like this as an outer join. Select the vendor name from vendors as the left outer join, invoices as I. I'm very happy I don't see anybody writing just left join. I would not be happy if I see that. So in this class, it is left outer join, no left joins. Right outer join, not right join. Notice that I renamed the table so that I didn't have to type vendors again. I renamed invoices so I didn't have to type invoices again because I hate to type. And then I say where I.vendor ID is null, so it's pointed at the vendors table. So the left outer join points to the vendors table, and then it tests where the other one is null. And it's pretty straightforward. If I were to put that over into my here it is. Execute, and I get 89 rows. And so I have 89 vendors that don't have any invoices. Okay. Now I'm not guaranteed that vendor name will be unique. I could have two vendors that have the same name, and that's possible. But right now I'm not going to worry about that. Okay. Now, in this particular query, everything that is selected for return comes from a single table. When I see this condition, it is easy to write that query as what we call a subquery. Okay, now that's the topic of today's lesson, the subqueries. Now, I personally like subqueries. I will typically write a subquery instead of a table join. I can usually write if I need to have a table join, if I have two tables in a query, I can usually, more often than not, write it as either a table join or a subquery, my choice. Sometimes one is easier than the other. Sometimes one is more intuitive than the other. In this case, that's about 6 of one and half a dozen of the other, so I'm going to use this as my first example. Now this is the subquery. I want to select vendor name. Now, the thing that makes this real easy to write as a subquery, everything comes from one table, vendors. Okay. When I see that, my life is simple. I can do it either way. I don't care whether I write it as a subquery or a table join. So here it is as a left outer join. I could have written it as a right outer join also. By switching the tables. Select vendor name from vendors. Where the vendor ID is not in, select vendor ID from invoices. Let me pause a minute and let that sink in. Questions? They are the same. They are exactly the same. They have the same runtime complexity. They will give you the same answer. Now, let's see, do I have an order by? They may not be in the same order. Okay, that's the difference. So if you put an order by vendor name there or an order by vendor name, they will be exactly the same. I don't know that they're going to be ordered the same way. So what did I get when I ran the top one? Execute him. And I got 89 rows. It began with the U.S. Postal Service. They are not alphabetized in any way. I can add order by. Let's see what happens when I run this one. Let's see if it looks similar in terms of order. I will get the same. I will get 89 rows. And notice I got the 89 rows. They look to be ordered the same way. I'm not sure that they are. Before I can say that they will be ordered the same way, I would have to add an order by something. In the case of the first one, they're a little bit different because in the case of the first one, I could order by anything that is in either table. But in the case of the second one, I can only order by something that's in the vendors table because the vendors is the outside table here. Questions? Now, I like subqueries. I like them because they are intuitive to me, more so than a table join. I can see this one easier than I can see this one. We're going to use them both. And as we get towards the end, now right away, I'm going to say, I want you to write a subquery, or I want you to write a table join. So I want you to be able to do either one. But in the real world, some people will choose a table join, and some people will choose a subquery, just like some people will pick up a hammer, and some people pick up a screwdriver to, I guess that's not really a very good one, but sometimes people will design a circuit board to do something and design the logic, and somebody else will go out and buy a microprocessor and program it. They'll both accomplish the same thing in whatever it is they're trying to build. The circuit board will be a little bit cheaper, but they'll spend a lot more time designing it. So all of life is a trade-off. But by and large, these are the same. Let me look at what I have said about it over here. The syntax requires the parentheses. Okay, these parentheses right there, that set of parentheses is required. And I prefer, just on matters of syntax, if you would not mind, please align the open set of parentheses and the closing set of parentheses. Some people will do it like this. Yeah, that's cool. I think I have two tabs in here. That just came from my copy and paste. That's the way I'd probably write it, because I like having the open set of parentheses match the closing set of parentheses. And whenever I can do that without really being tedious about it, I will always try to match the parentheses, the open set directly above the closing set. Some textbooks will write it like this, and this would be valid syntax. I do not care for that syntax at all. The reason the textbooks do that is because it makes the text feel shorter, so they get more stuff on a page. But we're not worried about that in our. Okay, so N is a set operator. So where the vendor ID is not in this set. So N is a test to say, is it a member of it? Got a couple of other things here. Some people believe that a subquery is more intuitive than an outer join. Yep, one of them's talking to you right now. Most of the time. It's up to you. In general, a subquery is not any more or any less efficient than a table join. And Professor King, in the video that I gave you, he raised a good point. Do not use the distinct keyword in the subquery. In other words, if you put select distinct, some people think that you need to limit this to where the vendor IDs, I can't have any duplicate vendor IDs. It doesn't matter whether you have duplicate vendor IDs in this subquery or not. Doesn't hurt you a bit, because this it's either in the set or it's not in the set. I don't care whether it is a distinct set, meaning I don't care if I have duplicates in this guy, it doesn't bother me a bit. So if I say distinct, I'm simply making the system do more work that I don't need for it to do. And so this is a place where I can hurt the performance a little bit if I say distinct. Other than that, they are exactly the same. And let's see if I have anything else over here. Okay, I guess I don't. Next one. Subquery module 2. Okay, subquery, this one. Oh, I love a subquery for finding a maximum. Find a maximum. Find me the records that maximize the some value. Okay, so find the. I have a table of scores. So person A has a score of 27. Person B has a score of 26. Person C has a score of 20. Person D has a score of 27. Notice I have I have a tie there for 27, and I want to find all of them that have that maximum value. Where ties are in there. I'm not just interested in what the maximum value is, I'm interested in who has that maximum value. And this is where the subquery really comes into its own. Now, if I didn't have a subquery here, I could use a group by, and so let's say I want to find the vendor ID or vendor IDs because we might have ties. I don't believe I have any ties in there. I should put one in there with the highest invoice total. Now the vendor ID is part of the invoices table, so it's okay. And I could use a group by here. So I could say select the vendor ID, the max invoice total, invoices grouped by vendor ID, order by IT invoice total, ITOT. And then I say, well, okay, go look at it. So if I were to run that, I think I have it here. Yeah, here it is. So when I execute this guy, I want to find that vendor ID 110 has the maximum. And if I had another one that was tied with 110, he or she or it would appear either just above it or just below it at $37,966.19. I say, well, just go look at it. Any fool can see it. And this is considered sloppy. Return more field than I was asked for. I didn't ask for the, let's see, what did I say? Find the vendor ID. I didn't ask you for the total. I just said the vendor ID. And this is where we love having a subquery. This guy will work very nicely here. I want to find the vendor ID. So I'm only going to give you back the vendor ID. So all you're going to see here is 110. And if there were any ties, so for example, if vendor ID 72 had been tied with 110, I would have seen them both. If I had 10 people tied for first place, I would see all 10 of them. From invoices, where invoice total is in, select max invoice total from invoices. This one will work in any platform. If you have to do this in Access, then you will need to create a query. You'll have to create the subquery. He'll have to be a different query. So you'll create this query and save it, and then select vendor ID from invoices where invoice total in, and then you'll name that query. The interesting thing about this is that I can run the subquery by itself. If I highlight the subquery and I say execute, notice that I see the value of max. I don't see the column name. I don't have to give this a name. If you want to, you can. So there's nothing wrong with giving it a name. Since you're not selecting it, and you're not output, that's not part of the output, it's just being considered there. It's not necessary that you do that, but you may. And when you run this guy, you're going to see exactly one value. 110 is the vendor ID with the greatest. And had there been any ties, you would have seen them also. So if you want to name the row in the subquery, there's nothing wrong with it. What if I wanted the invoice total also? Up here, I got the invoice total. Well, what if I wanted it? So, boom. So let's add it here. Vendor ID, max invoice total is my max. Now here I need to give this guy a name. Why? Because he's part of the output. This one wasn't part of the output, so if you don't want to name it, if you don't want to give him a name, but you should never see in your query a field that is output and it says no column name. That's kind of a big bad no-no. So since he's not, all I'm printing is the invoice ID, it's okay not to name it. In this case, I have to name it because he's being selected from invoices where invoice total is in, select max, yada, yada. And why doesn't it work? When I try to execute this, I get, oh no, I hate it when that happens. I got an error message. Why? That's not a rhetorical question. You may answer.
I'm sorry, could you show the error message again?
Oh, sure. Actually, that tells you quite a bit about it. Invalid in the select list. We broke our new rule from the aggregate functions. Notice that I have an aggregate and I have something else. When I have one or more aggregates and one or more something else's, what has to be true about something else? He must be in a group by. Now, I get to see the vendor ID and the max. Questions? Now, notice everything here comes from the invoices table. That makes it nice for a subquery. Anytime everything I want comes from one table, I'm almost always going to reach for a subquery. It's just very, very common. But life isn't always so nice to us. I want the vendor name. Well, duh, the vendor name isn't in the invoices table. Where's the vendor name? It's over there in the vendors table. So now I don't have this nice little world where everything comes from one table. What do I have to do now? Oh no, I have to do a table join. But I thought I didn't want to do a table join. Well, guess what? If you want something that comes from two tables, if you have to return information from two tables, you're pretty much stuck with a table join in there somewhere. The fact of the matter is that I can still use a subquery to decide which fields, but if I need the vendor name and the maximum of the invoice total, I don't have any choice but to have invoices and vendors. Hey, I got to have something from both tables. I got to have both tables in the join, or both tables in the query. That's just something I got to get over. But I can validate them against where the invoice total is in. Now I can use the subselect to pick out which rows I want from that join. The system is very, very good at deciding which one is best, a table join or a subselect. The system has the full rights to, if you write a subselect, the system can change it to a table join if it decides that will be better. If you write a table join and the system decides a subselect is better, it's perfectly free to just change your query into a subselect. So it really doesn't matter which one you write. The main thing that you can do to hurt it would be down here on line 83 to put, say, select distinct max, because there's only going to be one max. But if you say distinct, then it's got to go through and check to make sure that it's, I don't know, I wouldn't do that. It doesn't make any sense. So keep these subqueries as simple as possible. And subqueries. Okay. So I pretty much covered this page. Next page. Next page, it gets a little bit of philosophy. And I tend to be one that worries about matters of philosophy. And when I write equal to, I insist on equal to means is the same thing as. So when I put that equal sign between two things, it is important to me that they be the same thing. So talking about, does a candy bar equal 75 cents? Well, a candy bar costs 75 cents in the vending machine, I guess. I don't know, probably more than that now. But that doesn't make them equal because one is money and the other is the product. But we will tend to confuse the two sometimes, and we'll say number 204 equals 75 cents. No, the price of number 204 on if I enter 204 as the product I want, might be 75 cents, but that doesn't mean that it's equal to the thing that's in there. And that gets confusing in database. The previous page we saw this, and I've made it blue in. So select vendor ID, max total from invoices where invoice total is in this guy. So where he's in this set. Now, notice that this set, this set that's here, returns one value, max invoice total, one number, one row, one column. It's just simply a number, but the result of this query, and if I were to run this query, I think I've got him over here. If I were to run this query and I execute, and there he is, it's $37,966.19. Is that the value that's returned? No. What returned from this was the table. This is a table. It has one row and one column, and in there is a number. So this is not a number. Now, I'm kind of getting on a soapbox here a little bit, but in where invoice total is in that is not the same thing as is it equal to it. Are you with me? Invoice total is a number. So actually it's money, but money is a number. Invoice total equals, well, what is this? This is a set. So where this number is equal to this set, folks, they are not the same thing. And everybody says, well, get over it, Smith. Someone have a question?
Nope, agreed.
Okay. So when you use that equal, if you execute it this way, it will work. This will work. If you execute this, it will run. Everybody argues with me on it, but that's fine. I tend to, even in the advanced class, I tend to hold the line on this one, because if you're going to test if it's in the set, you should say in instead of equal. In is just better. It is, even though the equal sign will work there, it just changes it to in. It only works when you have exactly one value and one column. If you have any more than one value, it won't work. You have to say in. For example, I could find vendor ID and the invoice total where it's in. I could say select a range of them. I want to find everybody that's within 10% of the average. It gets a little tricky there, and I probably wouldn't do that to you. I might use it as an example, but I could find everybody that's within 10% of average. Bottom line, I don't like equal.
Question?
Go ahead, please.
Didn't you say that the select max would return ties? So if you had a tie for the maximum, you had two values, then the equal will fail, right?
No, it won't, because what is in the subtable is just one value. You're not going to get select max is just going to give you back one value, the max. It's going to put them all together. So it won't give you, if the maximum were, what was that, 37,000 something, you're not going to get 37,000, 37,000, 37,000. You're just going to get one value. So yes, it will work. Where it would fail would be if if the subquery said select everything that was above average. And I think we've got that one coming up. I think I use that as an example. So everybody that's above average is equal will fail. Okay.
Thank you.
Mm-hmm. And let's see. Let me go on. Okay, let's talk about greater than. Okay, here's the one where it's above average. So this one, select AVG, is still selecting an average. I could say, I could rewrite this, and I think I will. I'm just about, well, got 5 more minutes here. I probably will rewrite this. I will probably keep going on this topic on Thursday. I don't think I'm going to finish it tonight. But notice this one. Select the vendor ID and the average invoice total from invoices where the invoice total is greater than. Select AVG invoice total from invoices. Again, I'm in that same situation. Equal to, greater than, less than are very similar operators, and they need to be the same thing. So I'm talking about the invoice total is money, and the average, select average invoice total is a table that contains one value. If the table contains one value, then it will work. And my advanced students are always getting after me and say, of course, by that time they're pretty high-powered programmers, or they think they are anyway. And I'm always arguing that these are two different things on either side of that greater than. So this is a number, this is a table. But if there is just one thing in this table, it will work. Now I can fix the one with equal. Instead of equal, I'm going to always use in. I'll never use equal, always use in, even though equal will work. This one, I can fix it by changing it. Instead of saying where the invoice total is greater than, I'm going to say greater than, I'm going to use the word all. Is greater than all, greater than everything in the table. So what is on the right side, excuse me, the left side of that inequality is money. What is in the table is money. Everything in the table is money. So the comparison now is between things that are of equal type. We're going to have a whole chapter on types, data type. And so now it makes sense. Invoice total is greater than everything in that table and in that subselect. And if it is just one item, which it usually is, well, hey, that's fine. Greater than everything. If it's greater than the one, then it's greater than everything. Hoorah. So I will always write all, and I want you to do this. Please humor me here. So when you're writing greater than on the subselects, don't just say invoice total greater than, select the average, say greater than all. There's another one that is not used as much. There's another one that says greater than any, which means that it is, let's see, greater than any. It's greater than anything. If there's anything in there that's less than that, then it's, but most of the time you say all. Most of the time you want it greater than all, because all works on, well, I guess any would work on one. So if there were only one value in there, you could say any or all would be the same thing. I typically write all because all makes more sense to me. I have to stop and think about what any means, greater than anything in that table, and I don't like having to think. Oh, let's see. Read about any, some. Oh, I'm not sure what some does. They're used very, very rarely. All is now comparing every element in the set instead of the set itself. So now the subquery or the cannot possibly, the above cannot return more than one value. That's fine. If it does return more than one row, all still works. One point in using all behavior on null. If the subquery is null, returns no rows, both greater than, less than will be true. Both will always be false. You have to be careful with null values here because sometimes they will have strange behavior. If the subquery is null, the subquery returns no rows. Greater than everything in there, if there is nothing in this subquery, then everything will be true. If the subquery returns only rows with null values, then both will always be false. Now that doesn't happen very often. Most of the time when you select something, but how could you get an average that would be null? Well, what would happen if you didn't have any values in the invoice total field and you're trying to take the average of nothing? It would return null. In that case, it would just be false, and so you wouldn't get anything. But you have to keep that in mind, and you have to think about that. Is it possible to get a subselect that returns no rows? And another thing is, could you return a null value? Try and take the average of nothing. And these are going to cause some strange behavior in it. So you need to be aware of that. You don't usually hit that problem, but nulls, we have a saying in database that null gives us a, nothing gives us a lot of trouble. So on invoice total, I would prefer not to have any null values in invoice total. I'm going to talk a lot more about invoice total before we get done, because that's a big error in this database, how they have done that. Invoice total should never be allowed to be null. It should be 0. So if you don't have anything on the invoice, it should be 0 and not null. So I can take the average of 0 just fine. It's 0. I can take the average of 50 zeros. It's 0. But the average of 50 nulls is null, which gives us a lot of trouble. I will bend over backwards not to have any nulls in my database. Let's see, bottom line. When you are comparing a value to a subselect for equality, use in or not in instead of equal to or not equal to. When you are comparing the value greater than less than, use the all keyword. And then I put a little disclaimer there. World of SQL programmers don't necessarily agree with me 100% in this class. Do it my way. Later, you might change. Okay. I try to say, you know, where what I'm saying isn't 100%, but in my opinion, this makes more sense. If I say invoice total is greater than everything in that set, it makes more sense to say that than is this number greater than the set. So there. Okay, let's see. We are at 6:53. And I'm about to open a bucket of worms. And I'm going to be on this bucket of worms for the next 45 minutes or so. Correlated subqueries. Here's what I want you to do, please. Would you go and watch Dr. King's wonderful presentation on this? It's very good, although he does talk fast. And we're going to talk about a correlated subquery is essentially, let me show you one. We have here's a correlated subquery, and notice that I have invoices. I have a table that appears in the outside, and the same table appears in the subquery, and they are known by different names. And that's the key to it. So I'm going to let you do the reading. You should do the reading, and you should watch that video, please, before we come back to class on Thursday. Will you do that for me? And everybody says, yes, Dr. Smith, we'll do that for you.
Yes.
Okay. I'm not ready to go into this one tonight because we'll be here until 8 o'clock. And neither you nor I would be happy. So we're going to start with page 4, correlated subqueries. I hope I have covered just the idea of the subquery. So most table joins, most of them can be written as a subquery or as a table join, and conversely, most subqueries can be written as a table join. Now I can come up with some that cannot be. Yeah. So you need to be able to do both of them. I suspect that as you program in SQL, you will come up with a particular way that you like to do things, and you'll tend to go one way or the other. I see students will, well, I personally prefer subqueries. With that, I'm going to go ahead and I'm going to bounce the meeting and get the recording processing. Questions may come now. Now I'm going to come back on. I'm going to log back in. So if there's any lab questions that you have, I'll be right back to take them. So basically, I'm just going to what I call bounce it. I'm going to take it down and take it back up again to where this starts processing. So I'm going to do that now. And I am now ending the recording.